So everyone's open up to C41. There's a note guide right here. I want you to scroll. This is a little note guide that I posted for you guys. I want you to scroll to the second page where you see this table. I want that on your screen, please. And then what I want on your desk is a piece of graph paper. I'm gonna come around and pass one out if you don't have that piece of graph paper from last Tuesday when we saw each other. So everyone's got this screen on right here, this screen on their, or that on their screen. Okay, I'm gonna cover what this means shortly. Your flip grid that you're gonna do today is basically you're just gonna tell me about this. And before you tell me about this, I have to tell you about it because you don't understand what it means, but you're about to right now. Have that ready. Right now, on your graph paper that I just passed out, go to make me an X and Y axis. So take up about half the page, X and Y axis. Go and write graph f of x, remember f of x means y, equals cube root of x plus 2. Graph f of x equals a cube root of x plus 2. So far, so good. All right, if we want to graph, let's make a table of values. Okay? So go ahead on somewhere on the left, outside the graph area. Let's go ahead and make an x. Instead of y, I'm going to put f of x. Because remember, f of x is still the same as y. It's a little higher level. We're using function notation here. Let's make a few values. How about -2, -1, 0, 1, and 2? How about that? What was that? Oh. Okay, so I'm making a table of values. I'll plot those points. I'm gonna plug these. Remember the function machines? I'm gonna plug these input values into the function, and the function is spit out an output value. And then I'm going to plot the points, and we're done. I don't know what else to tell you. Easy, right? Okay? So, first one. First one in line is -2. What's the function at -2? With the input at -2? Well, I'm going to rewrite the function. Wherever I see x, I'm going to replace it with -2. So I got -2 plus 2. What's the cube root of -2 plus 2?
0.
I want to say you're right. My coffee's kicked in.
Yeah, I'm right, mister.
Ooh.
You know why I'm right? Because I use my decimals.
Love it. You heard that, YouTube crowd? She used the Desmos.
Love it.
Absolutely. Absolutely. So we're graphing f of x. Here's a function. We're going to graph it. The first input in line is -2. So wherever I see x, I'm replacing with -2. And like Miss Diaz said, type this garbage into decimals, the scientific calculator. Let's see. The cube root of -2 plus 2. What's really, -2 plus 2 is 0, so it's really the cube root of 0. What times what to the third power is 0? Well, it's going to be 0. But if you, just for giggles, if you forgot, if you can't think, if you haven't had your coffee, like a cube root, I went to the scientific calculator, I just posted on C41. I'll press cube root. Cube root of 0. 0. Nice!
Oh yeah, you had your coffee.
So, When x is negative 2, f of x is 0. There's our first point we're going to plot shortly. Nice. There's our first ordered pair, in other words. Nice, nice, nice. Okay. I'm not going to plot them yet. Let me just finish the table, and then we'll plot all the points together. Let's just go back to the drawing board, our function machine. And the next input in line is what? What's the next input?
Negative 1.
Negative 1. So we're done with negative 2. Let's input negative 1 into the function machine. Here we go. So now, what's the function at negative 1 is the question. I'm going to use Dodger Blue since they're going to win the World Series again this year.
Yeah.
Negative 1 plus 2. Right, Rocha? They're going to win the World Series?
Yeah.
Right, Dominguez? They're the only Dodger fan, I think. You guys any other Dodger fans? I think you're a Dodger fan, right?
Yeah.
Yeah. My sister went to the Tuesday game when they clinched a playoff berth. She was at Dodger Stadium. And so I think we're guaranteed a playoff. Either first place playoff position or the wild card. Anyway, I'm not sure why I'm talking about that, but all right. Negative 1 plus 2 is a positive 1. So the cube root of positive 1, I want to say is 1. Because 1 times 1 times 1 is still 1.
Yeah.
1 1/3 power. Okay, cool. That was easy. I don't need to use decimals for that one, but go ahead and use it if you want. So when x is negative 1, f of x is positive 1. Cool. Rocking and rolling. Okay. 0.
1.3.
You sure?
Yeah.
I think Diaz is right. So 0 plus 2. Cube root of, so 0 plus 2 is 2. Cube root of 2 is 1.3 to the nearest 10th. I love it. You could type that into calculator if you want, but it's going to be 1.3. We're just rounding the nearest 10th for now. Excuse me. A breakfast sandwich. Hiccup. My wife made me a nice egg breakfast sandwich as her day off, so I was like, well, it's made me a good breakfast. It's awesome.
This is gonna make me hungry. Stop.
Sorry. All right. And the fourth input is a positive 1. So the cube root of 1 plus 2 is 3. The cube root of 3.
1.4.
You sure?
Yes.
Don't be offended. I'm going to just do it for the rest of the group.
No, never forget.
Cube root of 3. Look at that, guys. I'm just letting the scientific calculator do the work for me. Cube root of 3, 1.4. Thank you, Diaz. We're just rounding the nearest 10th. So far, so good. Awesome. And 2. Last but not least for now. Okay. So that's going to be the cube root of 4.
1.6.
1.6. It's barely moving up, huh?
Mm-hmm.
It's
curving.
yeah, it's curving up very slightly though. So the cube root of 4 is 1.6 to the nearest 10th. Let me make sure Diaz rounded correctly. Don't be offended, Diaz.
Never.
Yep, 1.6 to the nearest 10th. It's 1.58, blah, blah, blah. 1.6. I should stop doubting Diaz. What's the matter with me? What's the matter with me?
It's okay. Forgive you.
All right, let's plot these puppies. I mean, all I'm doing is showing you how to graph a function. Make a table of values, plug those puppies in, figure out what the y's are, and we're gonna plot them. We're done. We'll connect the dots when we plot them. This is not rocket science, you guys. You've seen this before. Here we go. -2, 0. Again, we'll go red this time for the Angels. Any Angel fans in here?
Mm-mm.
Good, so I'll send you to the office. Just kidding.
Well,
-2 zeros right here. -1, 1. Nice. 0, 1.3. 0, 1.3 is barely above. Right there, there's 1.3. 1, 1.4 is a little higher than 1.3, right? You can see it kind of increasing. And then 2, 1.6. A little past halfway. Look at that. Now, I'm going to connect those, but before I connect those, I'm going to check with the graphing calculator just to make sure that my work is accurate. Look what I'm going to do. Before I can connect these like this. Look at it. It seems like maybe the graph will go that way. I don't know what it's going to do after. Because I only picked 5 x values. If the domain is all real numbers, I don't know how the graph is going to behave later on over here on the x. If I start picking x values over here, I don't know how it's going to behave. So I'm going to check with my graphing calculator. Okay? I'm going to check with my graphing calculator. I'm going to punch this function in just to make sure that my graph is somewhat accurate. So the cube root of x plus 2, watch. It's on C41. Graphing calculator is right here. Desmos graphing calculator. Boom. Watch this. F of x. What the heck was that? Equals cube root. On Tuesday, I was looking for the cube root. It didn't have it. Notice the cube root button. It's in a secret location. Watch out, check it out. We're going to go to functions. We're going to go to miscellaneous functions and look at the cube root button's right there. So let me say that again. You go to functions, miscellaneous, cube root's right there. So I'm going to put cube root of x minus, was it x plus 2 or x minus 2?
X plus.
Thank you. There's a function, guys. Look at it. Look at how it behaves. So we're right here. The only part that we did, right? The only part that we did was just this part. Come on, you're killing me. We're only right here. We just had a we just graphed a small part of the graph. So now I'm looking at this graphing calculator just to make sure that my graph is pretty accurate. So I already know now it crosses the x-axis at -2 and then it starts curving this way. So let me go back over here then. So we already have the x-intercept. Oops. So go ahead and do that with yours now. It goes this way and it goes that way. Cool. All right. So far, so good. That's graphing. So we made a table of values. I made a few easy negative values, a 0 and a few positive values, plugged those puppies in, plotted the points, and then before I drew my graph, I made sure with the graphing calculator that my graph is accurate, and we're good to go. No big deal. Okay, so, next thing. All right. Let me, that's pretty cool. The black instead of. That look nice. All right. So there's a function we just grabbed. Now, what I want to do is just take a look at this graph. Let me forget the 2. What if we just had the cube root of x? What you're looking at in the screen is what we call the parent function. Parent. Think of what I'm saying. Right here is the parent function. Maybe not. What do parents have in their life? Kids. Parents have children, right? If that's the parent function for a cube root, because look at this, there's just x, and I'm taking the cube root of x, that's the parent function. A parent will have a child. And look at what the first child is going to look like. I'm going to put it right underneath the parent. I'm going to copy and paste. The child is going to be in orange. But look at this. What I'm going to do is, look at it on your screen. I'm going to shift the graph left or right by either subtracting or adding something to the x. Okay? Let me subtract 5 from x. What ends up happening if I subtract 5 from x, I'm gonna have a new function that's like a child of the parent, but it's gonna look a little bit different. It's gonna be shifted to the right. It's gonna be what we call a horizontal translation. Translation is just a fancy smancy word for sliding. To slide something is to translate something in math. Okay, so I'm going to do a horizontal means left and right. Vertical means up and down. I'm going to translate horizontally the parent function. And we kind of call it like the child. Like a play on words. Watch. Check it out. Rocha, what's your favorite number?
23.
What I'm going to do is actually just use Rocha's favorite number to create the child function. I'm going to add 23. Is that because of Jordan or what?
No, it's my birthday.
Nice. Watch this. All right, look at the child now. Let me zoom out. The child is in orange, and it moved left or right? Left. I added something and it moved left. You would think it would go right. But that's just the way the functions behave. And we'll get into that later. Let me go back over here. So look at your screen. Pay close attention, Rocha. This is the key right here. If you add something, it moves it to the left. These are just examples. I added Rocha's favorite number, 23, and it moved. The child function was 23 units to the left. If I subtracted 23, it would have been 23 units to the right. That's what's on your screen. We call that a horizontal translation. You have parent and children. Let me make another child. Let me move it up or down. But this time I'm gonna put the number outside the cube root function. I'm gonna do it outside of it, not inside. Notice the difference. Now the numbers are added or subtracted outside. That's going to move the function up or down. Watch. The first child was in orange. The second child will be in, let's see what the computer gives us. Another orange? That's boring. You know why? All right, so the first child is in blue now. The next child, Diaz, what's your favorite number?
12.
Watch this. The child function is going to be Diaz's favorite number, and I'm going to subtract it, her favorite number, from the function. And it's going to be outside the function, outside the cube root symbol. So here's cube root x. Watch this now. I'm going to subtract now outside the cube root, outside, not inside the way I did Rocha's favorite number. I'm going to do it outside. It's going to move, the child will be 12 units down. You said 12, right?
Mm-hmm.
Watch this. So look at the green child now. 12 units down. So here's a parent. Parents in red, the children are in blue and green. Okay? So we've covered horizontal translation, vertical translation. How about a reflection? A reflection is when you flip something over a line. Think about a mirror. If you look in the mirror, that mirror is like a that mirror is the point of reflection from on the other side of the mirror. You're looking at yourself, staring back at yourself. So you're on one side of the mirror, and your reflection's on the other side of the mirror, and the mirror's kind of like the point of reflection. Let me show you what I mean. Watch this. I'm going to erase the two children. I got rid of the children. The parent's going to have another child now, though. Look at this. I'm going to put a negative in front of the x. Look at this. Look what ends up happening. Actually, let me copy and paste. Copy. Paste. Purple child. But look what I'm going to do. I'm going to put a negative in front of the x. So that was a reflection like this. It reflected over, watch this now. It reflected over the y-axis. Since it was in front of the x, it was a reflection in the y-axis. That is to say, we look at the graph. This part right here of the graph is reflected over the y-axis. Here's the y-axis right here. This part is reflected right here. This part is reflected right here. So the y-axis kind of serves as the flipping point. Everything here is flipped right here. Everything here is flipped right there. We're flipping. It's what we call it, the fancy word is a reflection. Okay? If I were to put the negative, look at this child now. Look at the purple child. If I put the negative outside the radical symbol, then it's going to be a reflection over the x-axis. Look at this. It still looks the same, but this case, it was a reflection over the x-axis. So this is the point of reflection now. This is reflected right here. This is reflected right there. We're flipping over the x-axis instead of the y-axis. It all depends on where that negative is. If it's inside the square root, the cube root, or outside the cube root. Now, I've covered 3 of the 5 translations, 3 of the 5 transformations. I've covered right now, as an example, I've covered horizontal translations, vertical translations, and reflections. Tomorrow, actually Monday rather, because we're gonna only have the quiz tomorrow. Monday I'm gonna cover horizontal and vertical stretches or shrinks. But notice you have 5 of them. 1, 2, 3, 4, 5 types of transformations. We call these function transformations, parent to child. The child will resemble a parent, just like in real life, right? Your children are going to resemble you, but they're going to be slightly different. That's what the whole point is here. You get a function, you can manipulate it and make it look like you want. Just by tweaking a little bit, adding some numbers here and there, or some negatives here and there, you're good to go. Your flip grid is just telling me these 5 transformations. Just the titles, and you're done. And go on your problems. We're done for the day. We've got about a half hour. Have a beautiful day. I'll be rocking around to help. Your grades will be current tomorrow, so give me patience. We'll do a grade check, credit check, and the quiz as normal Friday. Have at it. Get big busy.